So carbon, and here I have the periodic table up here. I have also the arrangement to allow us to cross out to show us the order. Okay? So what we want to do is we want to find where carbon is on the periodic table. Okay? So it's on which energy level? 2, right? So we know that we are starting, we've got 2 electrons in the 1s, right? So in the 1s we have 2 electrons, right? Next, what's next? 2s, right? Which represent these electrons, right? These atoms. So 2s, and how many electrons are in the 2s? 2, right? So carbon is on which subshell? The P subshell, right? But it's on the 2p subshell. How many electrons does that P subshell occupy? How many electrons? 1, 2. Because remember, how many electrons maximum can the P subshell hold? 6. But for carbon, it only has 2, right? And now, do the other count. How many electrons does carbon have? 6. 1, 2, plus another 2, plus another 2, to give us a total of 6. So the electron configuration of carbon is as follows. So make sure that you're able to break down, right, that this is your S, this is, and this includes this S, right? Okay, this is our P, this here is our D, and that down here is our F. So we are occupying the first S's with 2 electrons on them. We are occupying the 2s with 2 electrons on it. We are occupying the 2p, but in the 2p we're going 1, 2 electrons over. Okay? So for carbon, the electron configuration for carbon is as follows. Okay. So let's look at silicon. Okay. So where is silicon? What energy level? 3, right? So we know it's 3 in which subshell? What? P. Right? So we know it's in the 3p. Right? So there's silicon in the 3p shell. So how do we get to the 3p? Well, we have the S to the 2s to the 2p to the 3s, and we stop at the 3p. So we start off 1s. We know we have 2s. We know we have 2p. We know we have 3s. And we know we have 3p. But now, we have to show how many electrons are found in each one of those subshells. So, in the 1s, how many electrons? 2. How many in the 2s? 2. How many in the 2p? 6. How many in the 3s? 2. And how many now for where silicon is? 2. Okay? So as long as you have this little chart here, and that you have the ability to break down, and remember, this is your S, which includes that. This is your P. This is your D. And down here, this is your F. And we said, how many electrons can be held in the S? 2. How many in the P? 6. How many in the D? 10. And how many here in the F? 14. Okay. So the maximum number really that you can have for any P would be what? 6. The maximum number you can have for any D would be 10. The maximum number you can have for any S? 2 electrons. Okay. So, try potassium. 1s, 2s, 3s, 4s. And that's it, right? So we have 1s, 2s, 2p, 3s, 3p, 4s. So in order for us to reach to that 4s, all these have to be full. Right? And how do we tell? We don't even have to look at the periodic table because we know that all the s's can hold up to how many electrons? 2. Except for that 4s because we are only occupying 1 electron in that s orbital. Now, how many electrons on all those p can hold?
That's so easy now.
Oh, it's so easy now. Yeah, it ain't that hard.
Because the K is right there. Because 4S is the 4th thing, the 4S, it's only K is right here, it's right here.
Okay, so are we clear with that?
There was calcium before us too.
Oh, are we? So if it was calcium, which one? It would be 4s? 2.
I just didn't get the last one. I didn't the beginning part, just like whatever it has.
Okay. There is a simpler way of drawing instead of showing all this, but we'll get to it in just a second. We meant when we were drawing our Bohr diagrams, and we were drawing, let's say our our atom, whatever atom X is, and we were drawing these orbitals. When in fact, these orbitals are really energy levels. So we have the inner energy level, the 1s, right? The 2s would be around here, but within this 2s, you'd have your p going within.